Okay, we can start, and we start. So what is client portal? First of all, this is dedicated workspace for your external users, like clients, contractors, freelancers that you hire for some projects, and a lot of more cases. Today, we will review the most popular cases, as I think, and then I will share. We will link and review on your questions. So the most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will link and review on your questions. So the most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will. Okay, now link and review on your page. So the most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will. Okay, now link up and review on your page. The most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will. Okay, now link up and review on your page. The most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will. Okay, now link up and review on your page. The most popular cases. Okay, as I think, I'm gonna share. Then I will share. We will. Okay, now link up and
All our spokes are identical. Whatever the equipment that we have in Kingston is the same equipment that we have in Rochester, and will be the same equipment that goes to any of the spokes that we build across the globe. So the plan is to build spokes here in Canada and ship them throughout the world, so that it can be more and more scalable and standard without any issue. So we take our batteries, we shred them by a mechanical shredder, and then we have hygiene ventilation, which is treating the off gases with activated carbon and carbon scrubbers, so that we do not send any off gases into the atmosphere. Then we have two screens where we separate out our shredded plastics and shredded foils, and we filter our filtrate solution into black mass. Sorry, I cannot go much into details of this process, as it is a patented process with patented composition of the black mass that we can generate over here. We accept all types of lithium-ion batteries regardless of chemistry, form factor and prior application. No need to separate different battery chemistries, so we can fully charge modules can be processed. We do it all the time now. All intermediate products are returned to the economy. Minimum clean water discharge. Over here is zero clean water discharge actually, and site maximizing water recycling, which is we are actively doing it right now as well. I'm sitting in the company only in my office. They're actually doing it right now. So we have zero impact air emissions. We have done like multiple testings. The impact of the air that we went into the atmosphere is free of any harmful chemicals or any harmful gases in them. Full packs at our Arizona facility, it's coming soon, probably in the next 3 months. We'll be breaking ground soon. And I also ran a pilot run on recycling of solid state batteries also, which is currently a challenge, but we did it in a very safe and sustainable manner, and it is the part of the same that we accept all lithium-ion batteries. This is the commercial spoke one. This is our feed conveyor. We feed the batteries in. It goes into a shredder over here. We shred the batteries. Then this one of the screens is showed over here, in which we collect either the copper or aluminum foils or the plastics. Both of them are the similar screens again, but just different areas of the plant. We have our solution handling circuit, which is automated, no manpower intervention, and we filter the solutions to get whatever the black mass that we make out of the batteries. This is our commercial spoke 2. So the difference between spoke 1 and spoke 2 is spoke 1 is a linear construction stick build, whereas spoke 2 is a module build, which is much easier to transport. We can transport it wherever we want on the world, and hence our plant will be the similar and not even similar, like exactly same looking throughout the globe, like life cycle patent plants. It's a good thing. So again, like it's a similar. We have the feed conveyor that goes into the shredder. We have the product outlet over here. Similar processing, just like one is stick build and one is modular. And then our hub. We take our black mass, we leach it out, and we have a reaction tank over here. We filter the black mass, we get it purified, and similarly all the processes, and we generate all these end products which are battery grade and can be used back into the battery manufacturing right away. Graphite, we're making probably 6/9 of the purities. Copper sulfide, gypsum, magnesium carbonate, cobalt sulfate, nickel sulfate, they actually go into precursor manufacturing. Sodium sulfate and lithium carbonate goes into the active battery recycling component. Hydrometallurgically, again, wet chemistry, low temperature operations. We do not provide any heat to the process. It's the exothermic reactions if any heat is provided into the process. We do recover battery grade lithium carbonate. It has been very difficult, we know, and again, like, because we recycle all types of batteries together, no segregation of LFPs versus LCA or LCO or NCO. All the batteries go in the system together, and we are able to actively or like recover battery grade lithium carbonate without losing any of the materials because of the say LFP batteries or any type of battery, and there's no intermixing of the components here and there. We recover battery grade cobalt sulfate and nickel sulfate, minimum solid waste for disposal, closed loop recirculation of water with minimum clean water discharge, site recycling, maximizing the water recycling, and zero impact air emissions. 34% less carbon dioxide production than the high temperature processes. So I'll get to this number again. Like I'll tell you how is it lesser and how we can reduce it even more. So this is we have done our engineering studies, permitting and infrastructure is all done. We are targeting to break ground by end of 2021. Like I said, like it's coming very soon. So there'll be a very big press release that we did break ground. Construction completion by 2022 and ramp up to start by early 23. And by 2023, we plan to process 25,000 tons of black mass annually, which is equivalent to 60,000 tons of lithium-ion batteries. Hub, the main materials that we are actively looking after is lithium carbonate, nickel sulfate, cobalt sulfate. Again, urban mining, high purity materials. They are future-proof, providing the building blocks of batteries that are not at risk of technological obsolescence. Unlike some like I know some of the companies and some of the research centers are working on cathode to cathode recycling process, but like these materials have to go in the battery, in whatever the battery is. So we're future-proofed in those terms. So why life cycle, or why our technology? Our recycling efficiency is up to 95%, even upping it to double nines or like 99%ish. Getting there soon. Smelting or thermal recycling, like I said, like they lose at least like 50% of the materials in due to heat they provide into the system. And cathode to cathode, they can recycle only 30% of the proportion, which is the proportion of cathode only in the battery. Battery chemistry and charge agnostic. We do not care about the chemistry of the batteries as long as it is a lithium-ion battery. We will recycle it, and we do not care about what the charge of the battery is. The system is sustainable. The system is safe enough to handle all the charge of the battery. We do not discharge. We do not dismantle any of the batteries. We have non-thermal, low-impact air emissions, minimal clean water discharge, including the hub and the spoke. Minimal human operating risk. Like I said, like the process is very safe. And there's like minimum risk present on the shop floor due to any of the batteries. And all our end products are future-proofed with respect to the materials that are coming out of the hub by the processing of the intermediate black mass that is produced at the spoke. So in pretty good shape around here. Currently, Rochester has 25 permanent jobs. They are operating on a 24/7 basis. The spoke over there. Once the hub will be active, we'll be actually making 120 jobs in Rochester. In Kingston over here, we're supporting 30 permanent jobs. Alabama will be creating 35 local jobs. Some of them have actually been created right now by breaking ground over there, and we have the warehouse and everything going over there. Similarly with Arizona over there, we're hiring people actively over there also. And like I said, the plan is to start recycling the batteries by January of 2022. Both Rochester and Kingston are R2 certified, and hence like we are certified by all the suppliers of batteries to us. No audits are required anymore. During 2021, like this was actually just the quarter 3 of the this was a very great, like very historical year in the history of life cycle as of now. Like every day is a history right now, but yeah, still. We added 14 new customers, one of them being the Ultium Cells, which is manufacturing batteries for I don't think I can take the name of the manufacturer over here, but it's globally available. So we are receiving the scrap materials from them also, as well as the batteries that they manufactured, which are in scrap condition. We are actively recycling them. We produced 524 tons of black mass in just the last quarter, which is financial 3 of 2021. So that will be July, August, and September. 524 tons. That's a really big number to produce out of 2 plants. And we recycled or provided the economy back with 85 tons of lithium carbonate equivalent, 75 tons of nickel, and 23 tons of cobalt back into the economy. Now coming to back to these, so we had a third party do a life cycle analysis for us to so that we can compare like what are our emissions. We offset 5.03 or 74% of the carbon dioxide as compared to mining and refining. Like this includes the raw materials that we receive are a part of our process that we have to use to do the recycling or convert the black mass into the required products. So a lot of that comes from like it is taking in place all the carbon dioxide that was emitted in producing those raw materials that we use as well. Same goes with all of them. We are offsetting 92% of sulfur SOx, like sulfur dioxide and sulfur monoxide and sulfur trioxide gases, as compared to mining and refining. 97% water usage. That's a big number. And like again, mining, we all know like they use a lot of water, so we are offsetting a lot of water by urban mining or secondary resource recovery. Same goes with NOx gases, 92% offset factor. So that is why I can proudly say the lithium ion global battery recycling problem is solved by life cycle. We are actively working on it. We are improving the process better and better every day, and we are leading the way to actively and creating a more environment friendly and a more sustainable and a green future for everyone on the earth. Thank you, everyone. I'll take the questions if there are any.
Thanks, Rishabh. Rishabh, thank you for giving a lot of spokes and lot of offset datas, because that's actually going to raise our bar itself. We have to strategically look into what exactly we are missing out in few of the LCA issues, which we need to come on tile. And it's always a pleasure of hearing you and Ajay always talking good about LI cycle. It would be a pleasure. Would be taking two questions if any are there.
Any questions?
I always knew Santosh.
Hey Rishabh.
Hi.
Hey Rishabh, Santosh here.
Oh, hi Santosh.
Great. So I had one question in particular. You did mention that all the batteries, irrespective of the chemistry, are going to a single chamber for shredding, right?
Yeah.
So have you ever had a ratio of what is the input and how's your efficiency on this rate? Because I mean, I just want to know the ratios.
Again,
have
like
you
it will
guys done
be
this evaluation?
We have done this evaluation, and I'm pretty sure I cannot say the number over here, but yeah, like just saying that by the terms of it, like like it does not make a difference to the hydrometallurgical process of it. Like whatever whatever the proportion we feed it in, it is still commercially viable to all of us.
That's right. I mean, definitely it's commercially viable. That's why LI cycle is into it. I certainly believe that. Anyways, that was the question. Thank you.
No, I'm sorry, Santosh, but yeah, like.
That's okay, Rishabh. We can understand surely that. I would just have one more question.
Yeah, thanks for the presentation. Biswajit here. I just wanted to know how much area does it require to create one facility, and what is the approximate investment that is required when we do such kind of thing at one place?
Okay, so our Kingston plant is actually not that big. It's probably 60,000 square feet over here. And I believe the cost of creating one of the spokes, which can annually recycle 5,000 tons of batteries, is close to 10 to 15 million US dollars.
Yeah, thanks. Thank you so much, Rishabh. Thank you, the audience, for asking these questions. And I'm sure there are many questions to be asked, because it's always a guiding force of seeing the examples of a life cycle and then coming in implementation. So Rishabh, thank you so much for this, accepting our invitation the last minute and enabling this good lecture on the teams. So we would be very, very happy that you would have been here. But anyways, next time when you come down, we will definitely meet on the occasions.
Definitely, sure. It was my pleasure too. And like again, like if there are any questions, like please, you can direct me. You have my email. Please direct to me. I'll be happy.
We'll be having a post-event session where we'll be tabulating the questions, and it can be forwarded to you for a reply directly to the question.
Sure.
Thank you so much.
Definitely.
Thank you.
Thank you so much. It's my pleasure. Have a good day, everyone.
Thank you all.
session here. It was a pleasure that you have been here. I'm sure it was very fruitful as well. We'll be having plenty of these good talks. Now break for a tea session. The tea is being arranged in the foyer. I would request Krishna to guide the delegates in attending the foyer. And on behalf of CSIR-NML and the team of battery cycling under the put up by the supporters, we thank all the people and we will be definitely having you join back soon.
Sir, our screen is visible, sir?
Can you hear
Jay,
us?
Yes,
yeah,
sir.
Jay, can you hear me?
Yes, sir. I can able to hear you, sir.
Yes, I could see ma'am's screen at the moment, but not the PPT exactly.
Yes. So you can move the slide also and check. Is the slide moving?
No, ma'am. Yeah, the slides are moving. It's absolutely. We have come to the energy key thrust area slide.
Yeah.
It's moving.
Fine.
Yes, please, can you put on the first slide, and we will keep the screen on. Yeah, ma'am.
Yeah.
Thank you so much. Thank you so much. I'll just give a call 2 minutes prior to the presentation starts.
Oh, sure. That's okay. The thing is, please ensure whether I'm audible. Okay. When I
ma'am, you're
start,
audible. I am actually sitting in the hall. You're absolutely audible.
then fine. Fine. Thanks.
Thank you, ma'am. Welcome back to all the attendees and industrial delegates. This is the second session would start in a while. The schedule goes like now we have Dr. Kalai Selvi, who is director of CSIR Central Electrochemical Research Institute, placed in Karaikudi. And ma'am would be delivering a lecture on the manufacturing of lithium-ion batteries, because it's being known to everybody that SICRI has been playing a very pivotal role in the country spearheading towards battery manufacturing. So I would request ma'am to please start the lecture.
Namaskar. Pleasant morning
Yes.
to every one of you.
Yes, ma'am. Absolutely. You are absolutely audible.
Thank you. Thank you. So first of all, thank you so much for CSIR-NML and especially to Dr. Chaturaj and the organizers for having given me this wonderful opportunity to meet the NML friends as well as industry friends who are there in the field of lithium battery, as well, especially in terms of lithium battery recycling. So considering my talk today, as already introduced, CSIR-SICRI is well known for its research in the field of electrochemical science and technology. And these days we are prioritizing electrochemical energy storage devices related R&D. And obviously it is having a major focus on lithium-ion batteries. Before I jump into that, I wish to gratefully recall the kind of opportunity which is being given by our headquarters, CSIR-SICRI, CSIR, which is functioning in the name of different themes. 8 themes are there, of which one theme is E2D, energy and energy related devices. And this energy related devices and energy based materials from CSIR family, 6 labs are taking the lead role, and the overall lead role is done by CSIR-SICRI. And this is where I'm just showing you this diagram on energy theme. So SIMFR is leading coal energy, IIP is leading petroleum energy, CSIR-NCL is leading hydrogen energy, NIST through Vanandapuram is leading these energy conversion and related devices. Of course, SICRI is leading these energy materials and energy storage. And finally, NERI is leading the energy management and the environment. Now, coming to the thrust areas of energy, as all of you know, there are 2 different areas in which the energy requirement is very, very obvious. One is green mobility, under which fuel cells, batteries, and supercapacitors are gaining importance. And especially in terms of energy storage, different batteries, particularly rechargeable lithium-ion, sodium-ion, redox flow, and futuristic means beyond lithium-ion chemistry batteries are gaining importance, especially with the current scenario is concerned. And if you just check the market needs, whether it is based on India or global market needs, we can just divide it into 2. One is consumer market-based portable electronics and e-gadgets as one family. The other one is EV and HEV as the other family. So for the first one of consumer markets and electronics, obviously both lithium and sodium-ion chemistry can do justice. And in the case of EV and HEV, this lithium-ion and lead-acid based hybrid electric mode can do justice. This is our honest opinion. And coming to the type of choice of batteries, obviously, as I told, lithium, beyond lithium, and hybrid technologies are gaining importance. Now, even in this post-COVID situation, all of us know that in India, this EV market is really coming up and it is progressing so very well, because in India, 90% of the total population, we are commuting by 2-wheelers, 3-wheelers, and buses also. And therefore, electric mobility with respect to this 2-wheeler, 3-wheeler, and 4-wheeler is gaining a lot of momentum during this post-COVID situation also. And one of the speakers during this inaugural session was beautifully making a mention about 250 gigawatt hour lithium battery demand in 2030. And he made a mention about even NITI Aayog's restrictions or the upcoming implementations that from 2030 onwards, all cars are expected to use only these batteries, or we can say that e-mobility is only going to be encouraged. So if it is going to be the very great deadline ahead, so in what way the country is now prepared enough to meet out this particular timeline? Actually, it is very optimistic to see that different areas across this nation, different companies are coming up with a lot of investments, whether it is from the Karnataka side or from the Telangana side or from Gujarat or from Tamil Nadu, that is near Bangalore, Hosur. So different companies are coming up and they are coming up with the megawatt as well as the gigawatt plans in the near future. So when this kind of efforts are going around in this nation, we from CSIR family, to what extent we are making the ground ready to meet out the requirements of this nation, maybe under Atmanirbhar Bharat or Make in India or whatever name you call it. CSIR is very much optimistic and CSIR is very much ready to meet out this challenging target. And we from CSIR Central Electrochemical Research Institute, thankfully, we started this lithium battery related research way back in 1990. And very great achievements, I would say, started from the year 2011 when we got some kind of a funding from CSIR through a project called TAPSON. So from the year 2011, we started showing visible progress in the field of lithium-ion batteries. So that time itself, we came up with a very small prototype fabrication facility in one of our Chennai centers. Because most of the industries, you may be aware that even though we are headquartered at Karaikudi, we have two extension centers, one in Chennai, the other one at Mandapam. This Chennai center is our showcasing satellite center for energy-related devices, mainly fuel cells and lithium as well as sodium-ion batteries. So that time in 2011, we started this small fabrication facility, and the capacity is 100 cells per day, and it is a cylindrical assembly line. It is 18650 lithium-ion assembly line. And that at that time the TRL was 4. Then after this TAPSON also, we kept on making number of improvements and modifications. And now today we are in a position that we are coming up in a big way in the level of megawatt hour fabrication facility. Special thanks to CSIR headquarters, Niti Aayog and CSIR Simpur. Now we have been given a huge funding from CSIR, and we are now coming up with the innovation center for next generation energy storage solutions. We shortly call it as ISENGIS. So this ISENGIS program, it started in the year 2020 and it will go up to 2023. So by the end of this project, 2023, our TRL it is expected to be greater than or equal to 8. And we are so ambitious that we'll be able to showcase that TRL level. And if you just see the country like India, wherein the lithium-ion battery market is expected to grow very, very fast, especially the CGCA AR is 32% till this year. And I will show one more data also in the upcoming slides. Now coming to, so this is the reason due to which CSIR has given this kind of a huge support to CSIR, Central Electrochemical Research Institute, to come up with this ISENGIS implementation. So phase 1 is augmenting the facility to 1000 cells per day. So it was in 2020 we started. So today we are now in a position which is very much closer to showcase and demonstrate this 1000 cells per day. I will show you a few photographs also. Machineries have arrived and we are closer to installation. Installation team is waiting for only visa approval. Once installation teams arrives here in Chennai, we'll be completing the installation, then we'll go ahead with some trial runs, then we'll go for the actual fabrication of 1000 cells per day in our Chennai facility. This is phase 1. When this phase 1 is now closely taking a shape, maybe we'll be showcasing all these things in the coming January, that is January 2022, we will be showcasing 1000 cells per day. But in the meantime, we are making the ground ready for phase 2. We have already floated our tenders for this phase 2 also. So here we'll be coming up with the cylindrical cells as well as prismatic cells. So this is our objectives. And when we are talking about this kind of fabrication and other things, yes, we do have some indigenization with respect to the cathode material, because in lithium battery, most of us, we know that 60% of the cast, it is having a dependence on the cast of the cathode material. And therefore, CSIR-SICRI is having number of patents, 2-3 patents on NMC chemistry, as well as we have some modified LFP chemistry also. So this is a kind of a bulk synthesis facility that we have at our CSIR-Sikri, Karaikudi itself. And this is our Chennai facility. So machineries like slurry mixture and coating line. I'm just showing only one or two photographs. This is an automatic winding machine. So all these machineries, they have already kept inside the dry room, and the installation is going to take place in next few weeks or maybe in the early January. But I'm hopeful that even before December, before Christmas, the installation will be completed. This is what we are optimistically looking forward. This is another exclusive testing facility that is housed very much closer to our dry room. So all the cells which are getting fabricated in the dry room will be shifted to this facility, testing facility, and they will be given all sorts of basic tests before they are getting dispatched for different applications. Now coming to the other one, whenever we say that, yes, we are coming up with a lithium battery, like my previous speaker, I should also say that a third-party validation or its matching performance with the global benchmark is very, very essential. So this slide tells you to what extent we are closer to the commercially available Samsung cell. And this is again another Sony cell we have taken, both in terms of voltage or in capacity. I'm talking about NMC chemistry. So whether it is weight or volume or size or its chemistry, everything is the same. And our cells are closely matching with the commercially available benchmarking performance giving cells. Now we started our journey with this kind of a cylindrical cells. We initially used them in torchlight, then we moved on to power bank. Then we started using them in solar lantern, and these days we are using it in e-scooter, e-bike, and e-cycle also. So when I said that this cathode, we have some kind of a technology also. So companies who are interested can really approach CSIR-Sikri for kind of lithium-ion cathode chemistry. So whether it is LFP chemistry, we have the modified LFP chemistry for which the TOT is viable. And similarly for NMC, for different variants, whether it is 532 or 622, we don't have technology for 811. I want to make it very clear. So we have the other variants of NMC, be it 333, 532 or 622, we have our technology. Similarly, we have parallelly, we are just progressing in the field of sodium-ion technology also, because lithium, definitely it needs the simultaneous support from the sodium-ion chemistry also. Here again, we have IP protected cathode, anode, and electrolyte based technologies which are ready for any interested industry to take it forward. So right now in India, no Indian company is making the, Indian companies are making any cells, and therefore this is high time that we can catch up, and this is what as far as the fabrication of lithium batteries are concerned. Just because the overall program of today or the conference or this brainstorming session is on ReBAT, I thought that I should share some of my views on even recycling of batteries also. So why batteries ought to be, especially lithium batteries ought to be recycled? The reason is very obvious. India's import of lithium-ion cells in the financial year 2021 itself is closer to 9,000 crore. And if you just see the economic value of the components of lithium batteries, whether it is cathode or the current collectors like aluminum or copper, or the active materials that involves lithium, cobalt, nickel, or manganese. So everywhere the cost is so very high. And this particular picture gives you one more idea that even in the year 2025, 70% of the cathode chemistry is going to be all around NMC. And therefore, we, in our recycling approaches, we are giving a lot of importance to, next to LCO, we give a lot of importance to NMC chemistry, and then we give importance parallelly to LFP chemistry also for its recycling. So when we just talk about the second life of lithium batteries, yes, it can be used for some stationary applications. It could be used for even electric power management and power grid stabilization also. I have given a list of few companies who are already involved in this particular area of lithium batteries second life assuring attempt. And I was very much excited to listen to the life cycles presentation. It was so very interesting for me. And from Sikri also, we have some amount of capability in extractive metallurgy. So I would say without any hesitation that in hydrogen, especially with respect to metals, I can say alkali or alkaline earth metals or basic metals, transition metals or lanthanides. We do have expertise, especially in terms of extractive metallurgy. Just because now we are talking about lithium battery, so our extractive metallurgy capabilities, especially with respect to iron, cobalt, nickel, manganese, copper, and lithium, that is giving us a lot of support. So when we talk about the circular economy, as everybody is aware of, there are two ways. Number one is, if you want to really ensure second life, one is you should recycle. The second one is you can even do refurbishing. This is what I think my previous speaker, he was talking about cathode to cathode also. I think he meant only that one. I'm not sure about it. So in the case of recycling, again, he was also talking about different types of hydrometallurgy, pyrometallurgy. He just talked about different types of heat treatment techniques and the 10 secrets of or 12 secrets of his company. And I will just showcase what and all we do from here, which are in line with other CSIR labs like friends like NML and IMMT also. Also, we do a lot of work in terms of refurbishing also. And if you just take the case of recycling, just because the previous speaker has given a lot of idea about this recycling, so I would say in a nutshell that even many companies are practicing pyrometallurgy, hydrometallurgy. I would say that hydrometallurgy is found to be far more advantageous compared to pyrometallurgy, because here I have given you a comparison chart of with respect to purity, quantity of the material, waste generation, usage of energy, capital cost, and production cost. So if you just compare all these factors together, hydrometallurgy really succeeds over pyrometallurgy. Similarly, when you just consider recycling and refurbishing, definitely refurbishing gets a little more priority than recycling for known reasons. So from CSIR also, we have this kind of recycling SOPs being adapted here. We are also coming up with NMC sulfate, especially NMC oxide, mixed metal oxides we are coming up with. And with respect to cobalt, we are coming up with cobalt sulfate as well as cobalt oxalate. And in the case of lithium carbonate also, we have the leaching efficiency of greater than 95%, and recovery is also 85 to 95%. With respect to LC and NMC, I'm talking about the recycling of LC and NMC. And this is our refurbishing. We are also collecting dead cells, and separation we are also doing mechanically. Actually, I have one point to be made a mention here. Here the collection itself in India, there are no systematic or maybe government arranged collection booths are available. So I think we have also written to the ministry that as an kind of an advice or a suggestion that collection booths are to be really given preference at this point of time. And second thing is separation also. The previous speaker was talking about shredding, and from the shredding he was talking about the black mass. Yes, we also do that. And here again there are two ways of doing the shredding. One is making the powder alone as a separate component, and the other one is, as he rightly told, whichever chemistry is involved, we can just do magnetic separation and non-magnetic separation. Either with a simple machine or from simple robots also. I think in India, the kind of infrastructure which has to be really given a lot of importance, especially with respect to the kind of segregation or shredding, I would say. We are also using a similar kind of approaches, but not in a big way. So when we are separating out the components, then we do play with the kind of amount of lithium that is lost. Because of this discharge, we just find it out using the analysis. Then we process the cathode material. By the time we do even apply washing as well as binder removal, then we go with the pre-processing of the cathode material. I just wish to make a mention here that apart from this recycling, why this refurbishing is gaining importance is, here we are not going to separate all cobalt, nickel and manganese separately or as individual components. Rather, we just collect the black mass. From the black mass, we just identify how much lithium is lost. That much amount of lithium is topped up. And once lithium is topped up, now the material is ready for second use. And yet another important point to be noticed here is, luckily the previous company, they are concentrating on battery grade nickel sulfate, battery grade cobalt sulfate, and battery grade lithium carbonate. That is very, very essential. Otherwise, nickel sulfate and cobalt sulfate of a different quality cannot be utilized directly as a raw material. That is one point. So these are the challenges which are associated with recycling. But in the case of refurbishing, we need not worry about whether we are worried about this sulfate or oxalate or oxide. Reason being, it is only topping up lithium, and you are just making another simple cooking by means of which the cathode is getting ready for the second life. And therefore, with these few words, I just want to say that refurbishing and recycling are the two options which are to be given a lot of importance in the coming days. And I do understand, I did not show the slide on how many Indian companies are also already involved in the lithium recycling options, because we know pretty well few companies are really doing good. And from Maharashtra, one individual person, he himself is doing as a kind of an MSME, he himself is doing this kind of a shredding, and he is making the black mass. And this black mass, he is able to immediately just push it to the market also, because we had a lot of interaction with him also. But anyway, in one form or the other, this refurbishing and recycling both are to be encouraged by the government of India. Collection booths are to be regularized. Then this shredding as well as segregation SOPs are to be strengthened. If these things are strengthened, I think recycling itself will lead to a lot of very, very efficient, energy efficient process, and that will give a lot of recovery. And refurbishing, of course, across the globe, there is no standard SOP for refurbishing, because depending upon the amount of lithium that is already utilized, the SOP will slightly take a variation. But refurbishing also needs to be given a lot of priority. And of course, I take this opportunity to thank NML once again to having given me this kind of a platform through which I'm able to even reach the industries, especially Indian industries, those who are working in the field of lithium battery. And also I take this opportunity to extend an invitation to all the industries, those who are available both physically as well as virtually, to make a visit to CSIR Sikri, Karaikudi, as well as our Chennai center in the upcoming days. Thank you very much, Dr. Chaturaj and the team, and I wish all the very best to the whole day proceedings. Thank you, one and all. Namaskar.
Thank you, ma'am. Thank you so much for bringing the entire insight about material demand, battery manufacturing as a whole, and some insights on the recycling attempts, what has been done at Sikri. I leave the floor for a few questions, except Santosh being the first.
Hello, ma'am. My name is Rajgopal. I was just comparing your presentation vis-a-vis the earlier one, and I note that the aspect of the electrolyte hasn't yet been touched upon. So could you give us some idea whether Sikri has also already looked at, say, electrolyte recovery, and how does it compare for both like direct conversion, say a direct battery recycling vis-a-vis a breaking up of the or recovering of all the metals separately?
Hello, ma'am, it was audible? Ma'am, are we audible? Okay. So probably there is, might be because of network glitch, she would have signed off, but we had a discussion that there will be questions after session. Anyways, now we would be moving to the next. Yeah, ma'am. Are you there?
Yeah. Sorry, because there was a thunder and the connection got disrupted. So just tell me now, because I could not listen.
We have a question from Ream Technologies. Rajgopal, can you repeat the question again?
Please.
Yeah, hello, ma'am. My question was relating to, say, the electrolytes in the battery.
Okay.
So you haven't touched upon that. So I was just wondering if regarding the electrolyte recovery is something that's already been worked on, because it was touched upon in the earlier presentation. And how does it compare vis-a-vis the direct battery recycling, or maybe like breaking out the different components?
So electrolyte, actually, right now we are not working on the electrolyte. We are working only on the cathode recovery as well as the anode recovery. That's why I said we are concentrating only on the black powder. And electrolyte, we have not given any kind of importance right at this point of time. What is your second question?
Sorry, yeah. My second part was that a direct recycling, where you're again converting the cathode into a battery material itself.
Yeah.
In that process, does the electrolyte recovery is it better in that process vis-a-vis going into a direct recycling or breaking them into all parts?
Yeah, even in that refurbishing also, we have never given importance to electrolyte because what we normally do is like the way we do discharge in two different fashions, as all of us know. Either we can use brine way or we can do even typical discharge. Then we go for dismantling, different types of dismantling techniques we use. Then we go and for the analysis, we once again take only the black powder. There also, we have not taken into consideration of this electrolyte. So I think it's a good point. You are asking me to give more importance to electrolyte. Maybe I'll just make it as a point. So right now we are worried about only to what extent this cathode could be reutilized for its second life.
Thank you, ma'am. We have a second question now. Anand.
Hello, ma'am. This is Anand Kumar here from Auto Fiber Craft. We are an MSME located in Jamshedpur. So the question I want to ask is like, we would like to know what are the opportunities for MSMEs in this lithium-ion battery manufacturing, and do you organize any technical sessions or some technical trainings where we can come over there and get to know more about how the battery chemistry and how to manufacture these batteries and all. We are really interested in doing this.
Sure, very interesting question, because once this phase 1 fabrication has started its demonstration, especially for the actual after trial runs, we'll go for the routine production. So at that time, definitely we are planning to have this kind of a hands-on training to MSMEs. So we will definitely inform you at that time. You can also visit. So most probably after maybe April, after March 2022, you can expect such kind of programs from our end. So right now we are not allowing anybody because installation is yet to take place and other things are yet to be completed. That's why maybe in April you can expect something of this sort. Yes, we will include, definitely.
Thank you, ma'am. Now we have a question from Renault Nissan. So it's being in Chennai. So what do you want to ask it from Jamshedpur?
Yeah. Great.
Yeah, good morning. This is Ailun Subramani from Nissan Motors. Nice to e-connect with you again. So we have met before a couple of times. So my question is, I'm glad to know that, of course, Sukri is, having a, let's say, a pilot manufacturing facility for 18650. Of course, I have seen the facility in Chennai. We have the lab next to that. And my point is, I understand that we need to have indigenous lithium-ion battery technologies, but at the same time, lithium-ion battery is almost becoming a commodity, right? From a supply and usability.
Yeah.
So, do we have anything to do, or rather offer to the country from a sodium-ion battery perspective? Because probably that would make more sense for a country like India. So, what is Sekri's take on this?
Yeah, I think this is very interesting to me, this question, because as I already told you, we are parallelly working in the field of sodium-ion batteries. Right now, we have already, it is also 18650 sodium-ion battery also, we are fabricating in the same assembly line. And even in that sodium-ion battery, we are now using it in the torchlight. Again, we are starting our journey from torchlight, like the way we started with lithium-ion battery. So sodium-ion battery, 18650 cylindrical cells are being fabricated in our Chennai center because it is suspended for the time being. Because as I told, now we are in the interim stage, but it will be once again continued from January onwards. So definitely different types of sodium-ion batteries also, we are having plans, a lot of plans also. So yes, we will be able to transfer even technology on sodium-ion battery for its fabrication. You can ask me what is the status at which we are in the sodium-ion battery. In 18650 cylindrical cells, we have already showcased 0.75 Ah till date. Our aim is to showcase 1 Ah in 18650. Only then we can make this sodium-ion battery comparable with the LFP chemistry of lithium battery. That is our ultimate target, for which we may require another 9 months time. So we are hopeful that we'll be able to do this kind of a matchmaking also.
Thank you very much. That's interesting.
And we have the last question for you.
Hey, mom, this is Santosh here from LI Circle. I have one question. You know, your entire pitch was emphasizing on the second life and refurbishing. We can do refurbishing in the pack level, module level, and then cell level. And post mechanical processing, you're speaking in the black mass level, if I'm right. So where is your focus? Is it only post the mechanical processing, or is it even in the pack level, module level, and cell level?
Yeah, right now we are concentrating only at the cell level because we from CSIR-SICRI, we are not doing any kind of a pack and module because for which we normally just outsource it to industries only. So we only come up with the fabrication of cells, especially cylindrical cells. So we are having plans only with respect to the cell level. So this is what we have just internally restricted our area like this. We will just play around the cell level.
Great, because that is definitely the biggest challenge by high drain applications to low drain applications, and an entire ecosystem has to be built. And thanks for emphasizing on it. Last question I will wind up with. What is the manufacturing wastage that you're looking at in the cell level?
What is the manufacturing?
Waste in the cell level that you're having currently in the lab scale.
Chennai, we are planning around 60 megawatt hour, and if it is used.
Yes, ma'am. My question was, what is the manufacturing waste percentage?
Percentage?
Of the production capacity. Manufacturing waste.
Base or waste?
Waste, ma'am. Waste. What is the kind of generation percentage?
I think once we just get started with this journey, only we'll be able to get an idea about this waste. But definitely, since we have both recycling, refurbishing options, we will definitely consider that kind of manufacturing waste also to be considered by ourselves for its further recycling. That is definitely it will be done because their refurbishing may not be possible. Definitely, waste will be utilized for our recycling.
That was awesome. And if any more questions are there, we can have our email directed to Dr. Kalaselvi and she would be happy to answer on that. Thank you, ma'am, for giving the enlightenment and the time of yours. So enlighten the audience over here about manufacturing, refurbishment and recycling. It was a pleasure hearing you again. And we look forward to having you sometime over here when the things are become okay. Have a nice day. Thank you.
Thank you. And sorry for the 1 or 2 minutes disruption because
no, that's absolutely okay.
Thank you. Thank you. Thank you.
Thank you.
Good day.
Next on the platform, we have Will. Will Tablot will be speaking on behalf of Argus Media. Argus Media is a company which gives you forecasting of metal demand for batteries, what is the kind of production across globe in India and Asia altogether. So Will will be our next speaker. Do we have Will on board? Yes. Thanks, Will. Yeah, you are muted, Will.
There we go. Can you hear me now?
Yeah, absolutely. So
Fantastic.
You can share your presentation and go ahead with the PPT.
Okay. Right. Can you see this slide?
Great. Crystal clear.
Great. Okay. Thank you very much for inviting me, and thank you to CSIR and NRL. My name is Will Talbot. I'm a senior analyst at Argus Media's consulting department, where I run our electric vehicle and battery materials analysis and forecasts. I'd like to speak a bit today about our assessment of global demand and supply of lithium-ion batteries, and also about the rise of electric vehicles. And if my slide, we'll go to the next one. There we go. These are just the usual T's and C's and notices, and a quick introduction about Argus. So Argus is one of the world's leading price reporting agencies. We have more than 1,000 people around the world in every continent. We publish more than 25,000 price assessments. on things like energy, so oil, gas, power, coal, fertilizers, petrochemicals and metals. And yes, that includes battery materials, so lithium, cobalt, nickel, etc. We also, in addition to this price reporting and indexation service, provide consulting services, which is where I work, as well as conferences and data sciences. So agenda for today, I'm going to talk a bit about our assessment of electric vehicles and then about the lithium-ion batteries going into those vehicles. So global electric vehicle sales have really skyrocketed in the past 18 months or so. In the three key markets, so China, Europe and the US, which are the largest global markets, we're seeing EV car sales of well over 1,500 a quarter for, I think, 3 of the past 4 quarters. This is obviously significantly up from sort of 2018, 2019. I'm just going to talk about Europe first and then go on to China just to kind of illustrate some of the trends that we've seen and to tell you about how or why some of these things are happening. So Europe is a good example. EV car sales in Europe have gone to well over 500,000 units a quarter in the past year or so. This is up from well less than sort of 100 in 2017, 2018. And really the driving force behind this has been effectively state intervention. So government incentives in the form of both tax incentives and also subsidies. And this has driven the EV car penetration up to now over 20% in the third quarter of 2021, up from sort of about 3 or 4% back in 2018, 2019. Another thing that we've noted, particularly in recent months, has been a transition from a transition from ICE to PHEV and BEV. So PHEV is plug-in hybrid electric vehicle, BEV is pure battery electric vehicle. And we really anticipate that we will, in the short term, see a shift primarily towards plug-in hybrids before then a larger shift towards battery electric. And the reason for this is really twofold. So from a manufacturer's perspective, or from a conventional ICE manufacturer's perspective, plug-in hybrid electric vehicles are easier or cheaper to transition to than ICE vehicles, than battery electric vehicles, because they have much more in common with ICE vehicles. They still have an engine, and a lot of the kind of infrastructure within the car is similar. They can then transition from plug-in hybrid to battery electric, and doing this in this stage process is cheaper than converting all of your production lines from ICE to BEV. From a consumer perspective, this can also be attractive because some people still have anxieties about range, for example, and perhaps are skeptical of a pure battery electric car. So this transition to plug-in hybrid in the short term before going to battery electric is well underway. But going into the future, we think that this transition will end up being fully battery electric for a few reasons. One is economic. So the battery price or the average battery price in electric vehicles has fallen almost exponentially over the past few years. And we think this will continue into the long term. There has been, I guess, a bit of commentary in the news in recent months because battery prices have actually started to increase because of some quite severe price rises in the raw materials, mainly lithium, but also cobalt and nickel sulfate. But we think that this is kind of a short-term effect, and we expect those underlying prices, particularly lithium, to revert down this coming year. And particularly in the medium term, we think that the supply-demand balance will lead to a reduction, or I suppose a leveling in those costs, and that will also mean that the battery price will decline because of things like economies of scale and other factors. The other thing that is driving this uptake of battery electric vehicles in particular is regulatory. So again, in the EU, we have CO2 targets This chart here shows the EU-wide tailpipe out target, and Fit for 55, which is still being discussed or is still being proposed, would effectively mean a reduction to zero in that limit by 2035. Our forecasts don't take this into account. We consider it a scenario. We haven't moved it fully because it has not been accepted at an EU level, and so even with these the current CO2 limits proposed for 2030, we still see a significant shift purely because of that limit on tailpipe out CO2. And the third factor, which again is not just limited to Europe, you see this in several other countries, are ICE bans. So several countries have announced a ban on the sale of new internal combustion engine cars. I think Norway is one of the first in 2025, and then you have some other European countries, the UK, Sweden, and I think Slovenia and a few other places in 2030, and then France and Spain in 2035. And we've also seen this to an extent in some states in America. So California has an ICE ban, as does, I think, British Columbia in Canada, and various other countries do as well. China, which is currently the largest EV market, has also had a very significant growth in EV sales. And this is particularly interesting because it has come despite a reduction in subsidies. So China cut subsidies for BEVs and PHEVs in early 2021. And despite that, we have seen sales continue to grow to new monthly highs, or indeed newer and newer monthly highs. Unlike Europe, the Chinese market is already dominated by BEVs. There are several companies which now specialize in electric vehicles in China, and so that has kind of leapfrogged, if you like, the PHEV stage, and we only expect this share to continue. I haven't got a slide on the US, but I will just talk about it very briefly now. So the US is the world's third largest EV market. It lags behind Europe and China, and we think that will remain the case throughout the next 10 years. The US has a few challenges compared with both those countries. Its infrastructure is somewhat less developed, and the level of targets at a national level, at least, is also lower, despite various executive orders from the Biden administration. But we do see quite significant growth in the US in sales, but it will probably lag Europe and China throughout the next 10 years at least. Just very briefly on India. So India is obviously a very large market. In terms of car sales, I think you're looking at something like 2 million units a year in terms of total cars. But the EV penetration is very small. It's a fraction of a percent. So this year to date, you've had, I think, just under or just about 8,000, excuse me, just about 8,000 BEV car sales. But what's really interesting is this kind of exponential growth. So you're looking at growth from sort of below the 1,000 units a year mark to, I think, over 3,000 last year, and now almost looking like it's on its way to about 10,000 before the end of the year. India, of course, has a very, as I think many people have said, a very strong 2- and 3-wheeler market, and that does have quite a high electrification or electric penetration. But most of those vehicles are using lead acid batteries rather than lithium ion. So there are still challenges here. Globally, we forecast that EV sales will reach 25 million units a year by 2030. That's cars, that's not including commercial vehicles, so buses, trucks, etc. And that is about a quarter of all global cars, all global car sales. And you can see Europe and China still dominating the market, the US somewhat smaller, and the other category there, which includes India, smaller even than the US. And now I'm just going to talk about batteries, or lithium-ion batteries specifically. So EVs will be the primary growth driver of lithium-ion battery demand. We forecast a demand of 1.8 terawatt hours a year in new production by 2030. EVs, I think, are about 97% of this, according to our forecast, well outstripping the portable electronics sector and the industrial sector. In terms of chemistry, we expect LFP to increase its share. So this year we've seen Chinese LFP output increase to half, and now I think more than half of its battery output, the remainder being ternary NMC. LFP, of course, has several cost advantages over NMC. It doesn't use nickel or cobalt, and that confers a price reduction. Historically, LFP has been limited by things like the total power output, but again, recently we've seen advances in this. By 2030, we expect LFP to almost totally dominate the Chinese market, as well as, I guess, emerging markets. So we see that LFP will probably be a strong contender on the lithium front for India. And we also expect LFP to become more and more significant in smaller vehicles, so city cars and things like that in Europe and North America. But we do think that NMC still has a role to play, so particularly NMC 811, and I've also lumped in NCA and NMCA, which NCA is obviously nickel, cobalt, aluminium, and NMCA is that plus some manganese, which we expect to start coming into the play in sort of the late 2020s. These chemistries are, we think, will still remain relevant in Europe and North America, particularly for the kind of higher end of the EV spectrum, and even in other markets, we think that that kind of high performance vehicle will still use 811 or NCA and MCA. We also expect new manganese-rich chemistries to come into play in the 2020s. So I know there's some talk of LMFP. We've actually lumped that in with LFP in this forecast. And we also expect LNMO, which is a kind of spinel chemistry, to start being used, particularly in Europe, in kind of entry-level and mid-range vehicles from the mid-2020s onwards. This will, of course, lead to a dramatic increase in the metals demand for these batteries. So this is just the cathode material demand. Lithium, we expect, will rise to well over 200,000 tonnes a year by 2030. Cobalt will kind of be stretched in two directions, if you like. There's a move away from cobalt-heavy chemistries like NMC 111 and 622, 523 towards low cobalt, so 811, and no cobalt, so LFP and LNMO. But at the same time, the total demand for batteries will be so great that we do still see a slight increase in cobalt demand to I think about 60,000 tonnes a year by 2030. Even more significant will be the growth in manganese and nickel. So manganese demand we think will rise to about 500,000 or just less than 500,000 tonnes a year by 2030, driven both by that LNMO chemistry and also by NMC. And nickel in particular, we think will rise to just over 750,000 tonnes a year by 2030, again through that ternary NMC cathode. And that is it from me. Most of the, or almost all of the charts and things that are in this presentation have come from our battery materials analytics report. This is a biannual report that has sort of long forward-looking stuff. So it goes 10 years into the future on supply, demand, prices, markets, etc. We also publish a monthly outlook. So this looks at kind of short-term expectations for pricing and also covers market news in all the major markets. And if you are interested in either of these things, or if you have any questions, please do not hesitate to get in touch with me. Thank you very much.
Thank you so much for a global insight actually on this. Just I would start the questionnaire from my side itself. Do you have some idea about how is the kind of LFP market growing up in India as well?
Yeah, so I think the biggest LFP market at the moment in India, I think, would probably be buses. And again, that LFP will probably be of Chinese origin. Yeah, that's something that we think will continue to increase. LFP has been used in buses for a long time now, even when the energy dense power ratings were quite small in comparison to what they are now. And we think that will continue to be the case in the future. I think because the Indian market is quite, I guess, price sensitive, particularly compared to, say, for example, Europe, that LFP chemistries, as well as perhaps these nascent sodium-ion chemistries, if they do, if you can reach the necessary power ratio, will be significant in the Indian market in particular. Yeah.
Great, thanks. I just leave it to the next question.
Hi, Will. This is Subramani from Renault Nissan.
Hi.
I represent automotive OEM. My question is related to a little bit future or far future. I see that you made a very good forecast of let's say lithium-ion battery market going up to 2030. And from an OE perspective or from a passenger vehicle perspective, what we also see as a challenge is range, right? So we always want to increase the range of the car or the vehicle, and that happens only when we make batteries which are more energy efficient or higher energy densities, right? Let's say volumetric and gravimetric both. So my question is, do you also make a forecast for all solid state battery, which is going to be the future? Could be beyond 2030. So what is your take on that?
Solid state, we don't have a kind of specific thing in place. It's, as I'm sure you know, it's very difficult to forecast the uptake or efficacy of some of these chemistries, which are, really still in a research phase. It's hard enough talking about some of these lithium-ion chemistries, let alone stuff that is still in the lab. We don't really, at the moment, solid state to become significant before 2030. And even then, there's still a lot of questions about, for example, other competing things. So, polymer, maybe lithium sulfur, and all these other technologies that there is obviously still a great deal of research going into. I would say, one of the kind of surprising things I think surprising things in the past year or past recent years, but if you've been looking at lithium-ion batteries for a while, has been kind of, for such a long time, a lot of the research has been into, higher and higher energy density, and moving from 111 to 52263 to 811. And actually, what's happened is it's been LFP that's come out and kind of surprised everyone by this what was relatively a kind of maybe perhaps considered a poor chemistry, and one that was kind of only suited for stationary and buses. And I think that kind of shows that no matter how good your chemistry is, it needs to be price competitive. And I think that's something that will be really important for any chemistry that is being developed into the future. Yeah.
Thanks, Will, and it makes sense. And I was also pretty surprised when I see LFPs come back, right, in this decade.
Yeah. Cool. Thank you.
Thank you.
Thanks, Will. The next question.
Yeah, hi, Will. Just a couple of queries. First one was relating to the EV batteries. Where do you see the growth coming in from? Is it from the passenger vehicles, or do you see that coming in from the logistics? Right. And the second query was...
Sorry, yeah. On that part, yeah, passenger vehicles. Passenger vehicles. There is, there will of course be some growth in demand from trucks. Buses already, are, I guess, quite strong contenders for electrification. I think there is still some questions about electrifying the very heaviest trucks. And I think that's something that various countries are going to have to grapple with I think perhaps sooner than later. But yeah, in our estimates, we think that passenger cars are going to be the biggest biggest contributor to that EV demand growth, at least in kilowatt hour terms.
Yeah. My second question was, do you see any competing technology like, say, hydrogen cells, which might impact the growth for these EV batteries? And if not, then do you see what is the biggest challenge or hurdle which might actually make this demand not materialize?
Yeah, so hydrogen, again, leading on from my previous point. So we think that hydrogen fuel cells are a really good contender for these really heavy trucks, so sort of greater than, I don't know, maybe 15 tons or whatever. The trucks that need to drive for long distances, that don't have time to charge for long periods of time. That is a use case where hydrogen is going to be, I think, viable. We also know, of course, that several OEMs have started hydrogen van production. Again, that's kind of a lighter powertrain, if you like, but the use case is one which precludes kind of long charging times. So for as long as for as long as charging is limited in EVs, in those specific and small use cases, and in the heavy use cases, I think hydrogen will play a part. But I don't really see it as being sort of competing. It's more complementary. It's EV for one particular use case and one very broad use case, and then hydrogen for these more smaller niche cases. On the topic of hydrogen, it's also very important that the sourcing of that hydrogen be green or blue. At the moment, there's most hydrogen produced also produces CO2, and when used in fuel cells, the overall CO2 emissions can be significantly higher than for battery electric vehicles. So that's another thing that that regulators will have to keep in mind: the availability of green or blue hydrogen as in order to for that to be significant. Yeah.
Hi, Bill. This is Devi from CS. NMC chemistries are changing. Like now, NMC 111 is no more, like 523, 622. Now it is 811. So cobalt percentage is coming down. So what's your view on the cobalt-free batteries? Like the investments in the cobalt for last 10 years, what are your views on the same, both on the investment and the research side?
So again, let me go back to this slide here on the metals demand. So again, it's maybe a bit difficult to see just because the total cobalt demand is quite small in comparison to the lithium nickel demand. We do see this shift away from cobalt, both because of performance reasons. So obviously increasing the nickel in NMC produces better results, and also for cost reasons, cobalt is very expensive. But I think what we're seeing is, yes, there will be a move towards lower cobalt batteries, but the total volume of those batteries will continue to increase so much that the overall cobalt demand will grow. Yeah.
Thanks.
And so for that reason, we think investment will continue.
He answered you. Okay. Thanks, Will. This is Abhilash again. It was a good interaction. Always, it's a pleasure to hear you and Mark comment on lithium-ion batteries and their dramatic change. And just to pronounce the audience who are not aware about Argus, Argus is a big group who does analytics on other metals as well, apart from battery materials. So they have got a big genre of data on rare earth, general base metals, and battery metals as well. So this was just a flavor of it. Mark speaks a lot on other metals as well. Yeah, thanks, Will, for even forecasting that. So thank you very much. Thank you for your time, and it was a pleasure interacting you on live session. But we will be definitely having you back in India sometime so that we can have a direct interaction and a bigger crowd over there.
Yes, I look forward to it. Thank you very much, Dr. Abhilash.
Thanks. Thank you. So the next on the list, we have Manish Dua, who would be speaking on behalf of Benchmark. For those who are not aware about Benchmark, Benchmark Intelligence is a group focused exclusively on battery materials. They have been talking a lot about the kind of demand of battery materials in India, specifically in Asia. And we have got offices in India as well. So I would leave it to Manish to start his presentation. Hi, Manish, you're there?
Yes, hi, Dr. Abhilash. Can you hear me properly?
Put it on PPT mode.
Yeah. Am I audible?
You're audible.
Okay.
The slide can just come up on PPT mode.
I hope it has.
Yeah, the side panel is still on. That's what.
Okay, let me just present it again. Is it okay now?
Yeah, you can just on the right hand side tab of your screen, there will be umbrella button which you can share so that it becomes a total.
I suppose it is in PPT mode from my end at least.
Okay, no issues. It's quite clear, so we can go ahead with it.
Okay, great. Thank you so much, Dr.
You can just put it on
Abhilash.
slideshow if there's a button like slideshow over here.
It is on slideshow actually. Yeah, it is on slideshow.
Okay.
Is it visible properly? Or
It's
should I change
absolutely
it?
visible. Just we thought to have it a bigger enlarged view. Please go ahead.
Okay, all right. Thank you, Dr. Abhilash. Thank you, CSIR and NML for allowing this opportunity to speak. So, I mean, distinguished colleagues have already presented a lot on the lithium-ion batteries, how the industry has moved forward over the last decade or so, and how it is supposed to move forward, along with trends on recycling and the recycling processes being described by Lifecycle and others who presented before me. My intention of presenting today would be to just focus on the raw material side of things, primarily to look at how important the raw material foundations are for a lithium-ion economy. So I'm Manish Dua. I'm a principal consultant at Benchmark Mineral Intelligence. First, just to have a quick intro of what we are and basically what Benchmark Mineral Intelligence does. So founded in September 2014 by Simon Moores, who's our CEO. And till January 2021, we were a team of 35 people, moving forward like 7-8 months. I mean, we have hired a few more people, so around a team of 40 odd people. We specialized, we are specialized on lithium-ion batteries.
Mr. Dua.
Yes.
We are not seeing it on slideshow, although it might appear as a slideshow at your end. What I'll request you is to unshare, open your PowerPoint on your desktop, and then share again. Can you please unshare?
Yeah, let me do that.
Then open your desktop, open your PowerPoint on your desktop.
Okay.
And then share your screen.
Yeah, let me do it. Is it visible now?
Yes. Now please go ahead.
Okay, great. So yeah, as I was into the intro of Benchmark Mineral Intelligence, we are a team of around 40 odd people. We specialize on lithium-ion batteries and the supply chains associated with it. I mean, actually, we were the ones who basically started covering lithium-ion batteries back in 2015 when Simon founded the company. So we have like 4 segments to our business. The first one is price assessments, where we cover the pricing trends and do the assessments for key battery raw materials, namely lithium, cobalt, nickel, graphite, cathodes, anodes, and as well as batteries. The second part is the forecasting, where we do the supply demand forecasting and cover the key news trends surrounding the lithium-ion batteries and the raw materials. The third part is consultancy, where we cover strategy development, investment planning, and feasibility studies for OEMs, for governments across the world, say US, Canada, Europe, and the Asian markets, investors, private equity houses, and as well as commercial banks. And the fourth part to our business is events, where we do live events for audiences. I mean, the last year has been struck with pandemic, so the events have largely moved to the online space. But yes, we do have our world tours or conferences on cathodes, anodes, and batteries, as well as battery mega factories. To name one conference, from the 6th to 8th December, we have our Benchmark Week for online events for which if anyone is interested, we can get in touch, and those are live passes, basically free passes for those events. Moving forward, so yeah, the presentation before me already covered on how the EVs have moved, and basically I'll just touch upon it a little in brief on how the industry has moved forward. Basically, it is a convergence of industry and policy. Every major automotive OEM has announced commitments in order to basically decarbonize their transportation fleet, and we are seeing the penetration is climbing steadily. We could see it would be more than 5% for this year. Besides the industry moving, the governments across the world have announced policies to support clean energy and the energy transition, particularly on the transportation fleet is concerned. A number of tax incentives, schemes, credit schemes have been rolled out by governments across the world, particularly in Europe, US, and China, and others will soon move forward. Again, we'll touch upon briefly on how the EV sales have moved forward. Again, the numbers are a little dated, covered till March 2021, but as we can see from the charts, the EV sales have jumped a lot over the last 12 to 18 months period. And with that, we could also see the Chinese cell production has moved in line with that, given China is dominating this market, as I'll cover in detail in the slides going forward. So this is just a schematic. I'll just play this tiny little video, basically showing how the battery mega factories have come up over the last 6 to 7 years in terms of announcements, and this number is going up as we speak right now. So. As one could clearly see that the number started from 2014, the first mega factory being announced by Tesla in partnership with Panasonic, and how the number has come to 200. As we speak, the number is more than 240 at this present date. And China is clearly dominating this segment. In terms of the announcements and the factories which have come up, the number for China is, as we are seeing, it's 149. And Europe is slowly catching up with 21 being announced and being set up, and US with 11 in the pipeline as well as being set up. So now we look at how this battery mega factory announcements and the lithium-ion batteries coming up will basically translate into the raw material demand and how this affects this space. So as we see, the battery demand growth, it is a huge curve this industry has to follow from, let's say, 2020 to 2030, with majority of the battery demand coming from the EVs and the rest coming from portables and consumer electronics and other segments. Now, what does this do for the critical battery raw materials? Basically, if you see, we are projecting a lithium deficit by mid-2020s, given the huge number of batteries being battery mega factories or giga factories being announced. So the demand is supposed to go up on a best case basis by 14%, on a worst case basis by 7%. If you look at CAGR, and if you look at the lithium market on the right hand side of this slide, we are predicting that the market will hit a deficit from 2021-2022 onwards. As we have already seen this year, the prices have risen a lot for lithium carbonate and lithium hydroxide. And if the supply doesn't come up, then this could lead to much worse deficits, which would basically lead to demand destruction and prices being rising on a very high basis. So what are the typical constraints for raw materials? We see three constraints. First is capital. There has been underinvestment in the sector over the last 3 to 4 years, and which basically is, which could basically cause more deficits going forward. Second is COVID constraints over the last 12 to 18 months, which have led to more supply chain constraints. And third is the skill constraints, basically, which is forcing the industry to bring new supply to the market, and basically it is increasing the timeline rather than shortening it. Now, what have low raw material prices done over the last before the pandemic hit, the lithium, nickel, cobalt, and other prices were trading at low levels. What have they done? Basically, they've lulled the supply chain into a false sense of security, which has led to basically financing of the midstream and the end use and lower financing on the extraction side of things. So this is just a schematic on how to look at the industry and basically divide it into 5 parts. First happens the extraction, which determines the price, supply, demand. Then you process the chemicals, let's say for lithium, lithium carbonate, lithium hydroxide, for nickel, nickel sulfate, cobalt, cobalt sulfate. So basically they take on the raw material cost and pass it on to the cathodes and anode producers, which again process these chemicals and manufacture the cathodes and anodes, and again pass on the majority raw material cost to cell manufacturers, which eventually pass on the cost to the OEMs, which are eventual price takers. Now, just to have a look at what constitutes a typical, let's say, NCM 811 cell. I mean, just trying to give a schematic of the cost breakdown. So, I mean, this is again just an illustration, so we don't need to go into current prices and other things. I mean, if you see the schematic on the left-hand side of things, 2/3 of the cost goes into bill of materials, the rest into manufacturing cost. And this bill of material is made up of, if you see on the right-hand side, the contributing factors. 25% of the cost basically comes from is contributed by nickel, 12% by lithium, 7% by cobalt, and about 1% of the cost comes from manganese, aluminium. Then about 2-3% cost comes from the anode materials, and the rest comes from electrolytes and other fringe materials, binders, additives, etc. And if there is a raw material deficit, then it could basically derail the EV rollout, as basically these higher, as we saw in the previous slide, couple of slides back, the eventual price takers are the OEMs. If the prices for the raw material rise, it would eventually increase the cost of the cell and the battery, and it would eventually go. It would eventually basically could derail the EV rollout, as higher prices would get passed on to the OEMs or the EV manufacturers. So let's take a look at a typical NCM 811 example here. At December 2020 prices, the cell cost was something around $88. The contributing elements being lithium hydroxide, nickel sulfate, cobalt sulfate. If we look at a worst case scenario, I mean, as we are seeing, the lithium hydroxide and carbonate prices have risen a lot over the last 4 or 5 months based on supply chain constraints and inflationary factors. It could, and we've already seen the battery prices have gone up. On a worst case basis, these prices could go up from $88 to somewhere around $118 on a kilowatt hour basis. So this could as an example, basically derail the EV rollout, given the higher cost which would get passed on to the OEM manufacturers and then to the consumers. So what needs to be done? I mean, in terms of if we look at economies of scale and technological improvements, that will not be enough to mitigate the raw material risk in the mid-2020s based on current technology roadmaps. If we see the lithium-ion cell supply, I mean, as previously covered in the last presentation, we are saying the same story, that the cell supply will go up given the announcements and the commitments. But where we are different as far as benchmarks opinion goes, we have seen the cell prices come down from 2014. The number is $290 to 2020, wherein we are seeing some numbers around hovering around 100. But in 2021, the prices, the recent trend which we have seen, the prices of lithium chemicals and nickel chemicals going up, so the prices have gone up. So this could basically, again, coming back to the point, derail the EV rollout, given the prices can go up. So again, looking at the raw materials, there is no geological shortage of the critical raw materials, be it nickel, lithium, cobalt, or manganese, and no shortage of customers. But what the market is lacking right now is shortage of financing. As we can see, this is just an example of lithium demand, the curve going up on a year-on-year basis versus the supply which is there in the market. And we have broken down the supply into operational, unfinanced projects, under construction projects, and recycled supply. And as we see going forward, there is a deficit in terms of additional new supply coming up. So there is clearly a shortage of financing, and new projects have to come up to meet the growing demand. Similarly for nickel, I mean, just again a market balance. If you look at the market is tightly placed right now, 2021, 22, 23, but going forward, during the mid 2020s or the late 2020s, there is a possibility of a deficit. So this could be the case going forward for nickel as well. And this is just an example of nickel sulfate, which is typically used in NCM batteries. Now, to understand the issue a little more in detail, why is extraction lagging behind, as I pointed out in previous slides? So extraction of raw materials is the longest part of the supply chain to develop, and it is also location constrained. So need to look at, I mean, just understanding this chart a bit more. Extraction takes about 5 to 7 years since the time a resource is found or a deposit is found. Whereas if you see other elements of the supply chain, chemical processing, cathode production, cell manufacturing, they take around between 1 to 3 years. So there has to be a clear focus on extraction in terms of increasing the production on the extraction side of things, which could feed into the chemical processing and eventually into cathodes and cell manufacturing. Again, underlying the point that significant investments are needed in the primary battery material supply chain to meet the expected demand for batteries. I mean, this is just a schematic for different materials: lithium, flake graphite, cobalt, and nickel. How much capex is required from 2018, in between 2018 and 2030? Let's say for lithium, around $24 billion of capex is required to meet the demand. Let's say for flake graphite, around $13 billion. For cobalt, we need more capex, around $50 billion, given these are high capital intensive segments of the industry. And what are the locations? For lithium, the exploration is being carried out largely in Latin America and Australia. There are some announcements done in Europe and North America recently. Flake graphite, Africa is a major market. Some mines are also coming up in Brazil and China. Cobalt, largely dominated by DRC. We are looking at new sources, and nickel being largely there in Indonesia and Philippines. Now, who are the holders of the supply chain? China, US, and Europe are right now, I mean, have China being the major dominating country or the region in this industry. Europe and US are catching up. If you look at, so this slide basically gives a clear picture of into who is dominating the industry in terms of stages. So China is basically, if you look at, we have basically divided the supply chain into 4 parts. I'm hearing background noise. Can I ask someone to mute it?
ये सब ठीक है, मिलेगा नहीं मिलेगा, प्रोजेक्शन क्या है, ये सब हम इसका दुकान है हमारा, ये हमारा.
Can I ask some gentleman to mute their mic?
एक चीज मैंने इसमें देखा, cobalt will be going down, manganese nickel will increase.
Dr. Abhilash,
प्राइस राइज है कोबाल्ट की, उसके चलते वो कोबाल्ट का रिजर्व्स भी बहुत कम है, रिजर्व उसका अल्टरनेटिव से उसमें कर रहे हैं, मैंगनीज और उसमें कर रहे हैं, मैंगनीज निकल बढ़ा रहा है, और ये जो हम सोच रहे कोबाल्ट में पैसा मिलेगा नहीं मिलेगा, वो मिलेगा, सही बात. अल्टीमेटली लिथियम फॉस्फेटिंग होगा.
Dr. Abhilash, can you hear me?
अभी ऑलरेडी चाइना वाला सब इंडिया में प्रोसेस बेसिस लिथियम फॉस्फेट चलता है, तब उसका नया जो आता है वही हैदराबाद में नेक्स्ट चलता है लिथियम फॉस्फेट. भाई ये हमारा लैपटॉप वाला ये जो पुराना.
Dr. Abhilash, am I audible?
दूसरा वाला.
Dr. Abhilash, am I audible?
Sir, you can start, sir.
Okay, sorry, there was some background noise. I could not speak back then. Yeah, so as I was continuing with my presentation, if we divide the supply chain into four parts, being extraction, chemical processing or refining, cathodes or anodes, and the last being lithium-ion battery cell manufacturing. As we can see, across every space, China has basically dominated all these segments, with Europe being distant second and US largely lagging behind. Particularly if you see at the chemical processing and refining stage, China has a major control over cobalt refining, over graphite, over manganese, and over nickel as well. And across cathodes and anodes, China again is basically dominating, given China's huge presence in the graphite segment. It has large refining capacities on the anode side. On cathode, as we have observed lately, Japan and South Korea are also catching up. So what has this done? Basically, this emergence, this concentration of markets being largely limited to China, it has forced countries to come out to basically develop regional hubs, which is to move away from global supply chains and to form like domestic supply chains. So US, UK, Canada, Germany, Finland, Australia, Indonesia are all pushing for more of the market. So as we can see from the schematic, I mean, the market is finding hubs and as we move along. And now, where is all this raw material going to come from? For nickel, we have seen Australia, China, and Indonesia as being the major sources. For cobalt, Democratic Republic of Congo being the one particular source which has all the concentrations. Others we're still to see. For lithium, the major sources are identified in South America, being the brine sources, in Australia's hard rock and spodumene sources. And there are some facilities that are coming up in North America, I mean, particularly with having DLE technology. Recycling bit, I'm going to skip a bit, given it's largely covered in detail by the previous presenters, including life cycle. So, yeah. So what are the raw material realities? The new generation of lithium suppliers don't need to be lowest on the cost curve to have a position in the market of the future, given the demand is huge and it will keep growing, and expansions need to come up at newer, higher cost levels. What's the second reality? Higher long-term prices will be required to basically incentivize these necessary expansions. And this is just a schematic I've played in terms of how the lithium carbonate prices have moved over the last decade. So starting from 2009, this is a trend we are seeing. So I mean, in 2015, the market went up quite a bit, peaked at around $18,000 levels, then had a crash, and it all came coming down till the start of 2020, and then from there the market is on a parabolic rise. I mean, right now the highest prices we have seen for lithium carbonate are around $29,000, $30,000 at China traded level. And the last reality being that all these productions will need to be flexible to meet the battery industry's moving targets, because not all of these productions will go into batteries. Some of it will go into other markets as well, given there are levels to battery productions. So as at Benchmark, we have highlighted and we have basically formed a methodology for battery manufacturers having tiers 1, 2, 3. So tier 1 basically classifies as being qualified by Western automotives, tier 2 being largely limited to Asian markets, and tier 3 being not moving into battery markets and basically into EVs or basically other markets. That's about it from my end. If there is any question, you can reach out to me, and happy to take questions right now. Over to you, Dr. Abhilash.
Thanks, Manish. I'm sorry for the technical glitch in between. We actually have got some big list of SMEs in this online forum, and because of that, there would be some discussion, and because of the anxiety, it keeps on going. So I'm very, very sorry about that. Manish, you there?
Yes, I'm here, sir. No issues.
Do you have any questions? Nobody to ask? Thank you, Santosh.
Yeah, thank you for the presentation. Vishwajit here. Just wanted to know, like, what are the risk factors associated with lithium-ion battery, like obsolescence? Like whether it is going to be stabilized very soon, or is there any risk factor associated with that where the technological changes or innovation may breach it? And second question is solar industry, which is expected to be matured enough, where the prices and supplies are streamlined. How long will it take for this lithium-ion battery or battery manufacturing to be stabilized, where the cost or pricing thing may not fluctuate and people could be able to forecast it in a stable way? Thank you.
Okay, thank you, Vishwajit. Answering your first question, so I mean, if we have looked at the trend over the last like 12 to 18 months or before that, lithium-ion batteries have largely been the major source of like, let's say, technology in terms of battery technology. We are seeing new technologies, we are talking about new technologies, one being sodium-ion batteries. I mean, I think someone pointed out earlier that they're working on sodium-ion batteries, and recently CATL, the Chinese major, also announced that a roadmap for sodium-ion batteries. But as far as benchmarks views go, we don't see sodium-ion batteries like stabilizing or like coming to stream, let's say, by the mid 2020s, around 2024, 2025. The other technologies being talked about is solid state. Again, I think in the previous presentation and the Q&A, it was covered about how solid state would move forward. Again, as far as our view on solid state batteries go, I mean, we see, I mean, it coming online or maturing around, let's say, late 2020s, around 2028 or 2030, somewhere around that. And coming to your second question, which was on the pricing and what are the risks which lithium-ion batteries possess. Again, the risk from which we see is primarily associated on the raw material side of things. I mean, if you don't have the supplies locked up, you and at optimal prices, you will see the pricing risk being factored into the cost of the cells, and which would eventually be passed on to the OEMs. So, I mean, the key for OEMs or for cell makers right now is grabbing the supplies. And as we are seeing, the prices are going up because there has been huge, what do you say, intransparency in the market in terms of like locking up the deals as well as finding the supplies.
Hi Manish, this is Devi. Hi Manish, this is Devi.
Hi Devi.
Hi. So specific to lithium and cobalt supply for the potential gigafactories in India, what's your view? It will be a bottleneck for the potential gigafactories, or you have any thought on it?
Yes. So for cobalt, what we have seen is, I mean, largely so let's try to look at the cobalt supply chain. The cobalt which gets mined is largely comes out of DRC. And the concentration or the refining is happening more or less in China. So there are two concerns to the market. One is the concentration of refining products coming out of China, and first is the provenance of the material, which is basically getting mined out of DRC. Again, labor issues and ESG issues surrounding that. Now coming to the Indian market, we need to look at what sort of factories or gigafactories are coming up in the Indian market. So largely from the announcements or the limited announcements we have seen, I mean, previously it was talked about LFP batteries being coming up, but yes, if we have NCM being the major dominating battery chemistry coming up on the cathode side of things, then we could see issues on cobalt supply. And I think that's my limited view on this point.
And on the lithium side?
Yes, lithium. I mean, we are already seeing. I mean, over the last 3 to 4 months, we have seen major lithium suppliers locking up deals with large OEMs, and lithium market is in a tight flux right now, given the prices for both hydroxide and carbonate have moved up like very sharply over the last, I would say, 6 to 8 months. And going forward, we are predicting that the market could be in a deficit if new supply does not come up. So yes, there will be issues surrounding lithium supply as well. I mean, one more point I would like to add is, I mean, you can cut down the intensity of cobalt in NCM batteries, but lithium will always remain. So lithium is a major component of lithium ion batteries, and that supply again is a major point.
Great. Any other questions in case we have? Yeah, Gaurav.
Hi, Manish. This is Gaurav. Can you give us some understanding of the share of different chemistries vis-a-vis its usage in terms of global scenario?
Okay, so as far as, I mean, I don't have a chart up with me right now. If you could just allow me, or I could just speak on it. So, I mean, as far as the global share goes right now, what we are seeing is, I mean, what we had initially predicted was that NCM batteries, NCM chemistry being dominating the industry. But as the recent announcements have come up, we have to rejig our announcements, our projections as well, and we see like a tight flux between NCM, higher NCM chemistry, NCM 811 plus, and LFP. So these are the two which will dominate. And going forward, by mid 2020s, we are seeing that the LMO or LMNO chemistries may come up, given how the development comes about.
Great. Does that answer you, Gaurav? Not exactly. Isn't happy.
Gaurav, I mean, you could reach out to me. I mean, I have shared my coordinates. Like we can discuss on it like further, and we can maybe share a schematic or two in terms of how the global cathode chemistries would look like going forward.
Sure, Manish. I will hand over your details to Gaurav so that he can catch up with you and get the details.
Yeah, thank you so much.
On behalf of the audience and NML, I thanks Manish Dua for giving your time and presenting the statistics of battery raw material and demand in India also. Thanks, Manish. Thanks for joining in.
Thank you, Dr. Abhilash. Have a good day, everyone.
Same to you. The next presentation would be on the podium, and that would be from Dr. Arpita Day. Arpita is associated as Deputy Director in the International Indian Consumer Electronic Association, and that is in India. So Arpita would be giving us insights away from the EV market, actually on the consumer battery demand and all that. Arpita, please.
Good afternoon, everybody. Uh, so it's just been like 2 minutes delay with my presentation. So I'm Arpita, and I'm coming from India Cellular and Electronics Association. That's basically, if we speak about ICA under the chairmanship of Mr. Pankaj Mohindru, it was founded in 2002 as Indian Cellular Association, and with the intervention of the government, it changed to India Cellular and the Electronics Association. So that's the apex industry body for the mobile and the electronic segment or the electronic industry. So we basically work with the center and various states for the policy regulation and formulation in various aspects. We specialize in mobile, but we diversify in other segments, as you can see, that we also are into IoT devices, medical electronics, automotive electronics, IT hardware. Another segment that's not mentioned here is basically the EV segment that's going to get launched soon. And so that's the areas and the sectors we deal with. Also, not to forget that we also deal with certain parts and technologies that are related to the agricultural electronics. So these are upcoming, so that's why it's not mentioned, but we do participate in all of these. So objectives here, as per the NP, the National Policy for Electronics. So the mobile phone targets are mentioned. The manufacturing to be for 1 billion units, production of $190 billion, and exports of 110 billion. Now our aim here is basically to increase, increase the manufacturing competitiveness here in India. So we've been, focusing on the manufacturing segment for the mobile phones, and henceforth, I'll come up to the relation or the correlation, you can say, why I'm highlighting more on the mobiles as well as the electronics, because the theme here is basically lithium ion, which is a part of the electronic products that we're dealing with. Second would be the bringing of the global value chains to India. And the most important part here is to build the domestic champions. That is, when you actually have the domestic champions, you are enabling one's economy to grow and flourish on their own, what you can say, basis. And henceforth, the competitiveness in the manufacturing segment automatically gets increased. So here, our aim, focus, is basically make India the global hub for manufacturing of the mobile phones and the electronics. So industry's vision and strategy is making us number one in the exports, where we should lead it by 2027. Why 2027? Because the COVID has impacted the industry so badly, and not just this, others as well. So it automatically has got delayed by a couple of years. So in that case, this projection has been shifted from 2025 to 2027. And our focus here, the key export HS codes, proper definition of the same, and henceforth that will be helping to build the ecosystem. So here are some numbers. The electronic manufacturing and the exports, which is shown as a comparison from 2019 to 2025, how we're going to flourish. In 2019, we can see the figure for the production was basically 75 billion, exports $11 billion, with the domestic market of $64 billion. Initial segments had, if you can see the mobile phones, then the domestic market, of course, has the major share in that. And others are basically for the exports we are trying to highlight. Other segments that have joined in, basically the newer advancements in LED lighting, the consumer electronic exports, and the PCBAs. Industrial electronics and strategic electronics are also a part of this. So numbers are basically mentioned here. For the mobile phones, it's for the exports specifically, it's USD 50 billion. And the other schemes that are actually supporting this are the various PLIs that have been proposed by the government, the specs, and the EMC part. So if we can go and see the bifurcation industrial electronics with the hearables and wearables, they constitute about the export of around 17 billion. And our focus here is basically the mobile phones, laptops, consumer electronics, IT hardware, which encompasses laptops and tablets. So why we are talking about these numbers is basically they'll be acting as a source to the main theme of this event, the lithium-ion batteries. So that is basically the numbers that I just wanted to highlight upon. From 2019 to the projections of 2025, we are going to look at a number which is 260 billion in terms of exports being 100 and domestic market share being 160. So domestic market also comprises of the mobile phones as well as the other segments that are covered. So electronic manufacturing to reach $260 billion by 2025. So these are some numbers in which projections can be shown as a comparison from 2016 to 2021, how we have, far we have progressed. So 40% growth can be seen in the electronics production. Then mobile phones specifically, if we talk about, from 60 million units in 2014, we've reached to 300 million units in 2020. There had been a slight dip because of the COVID that had impacted the industry, but then again we have come up and we are progressing so far. So that's a good projection, of course. And then coming down to the domestic electronic components market, that was around $21 billion in 2019. So digital transactions, what you can say, adoption, you can say, has come up after COVID had hit the industry, where people realized that you do not have to be physically present or you have to do the physical transactions. So digital media and digital platform played a major role here in this. And electronic export goods basically valued around $6,213 million for the first half of 2021. And it showed a positive growth rate of 60%. As in comparison to 2020, in the first half, that was roughly around $39,000 million. Sorry. So if you take a stock from 2016 till date, it's specifically for mobile phones. That's what I told, that we are into mobile phones basically. So if we can see the mobile production, that was 220,000 crores. That this number is of 2021, as in comparison to 2016-17, that was around 65,000 crores. Component manufacturing, roughly around 90,000 crores. Exports, the number can be shown as it has grown up till $3.1 billion in 2021. Mobile phone exports, it has been dropped to 8% from a comparison of 78%. That was a very old figure, but then we've been able to achieve this target. Last year, as I told, the dip was even lesser than this, but due to the impact of the COVID, this number had slightly risen, but then we are again going towards the decrease. So this is basically the numbers that are projected. 2016, roughly around $48 billion to this can't be minimized. So basically, it's roughly around $65 million. If you can see, there's another, which is slightly less as in comparison to 2019-20, just because of the obvious reason we all know. So trend of electronic manufacturing in India, projection from USD 67 billion to in 2020 to USD 260 billion. These figures have actually been revised after the central government intervention and slight changes because of the 2 years backlog that we all had faced. So there are certain schemes also. PLI, we are all aware, it's for the mobile and the electronics industry. Then the IT hardware came in, the telecom PLIs has come in. Talking about the segment of EVs and storage, PLI for ACC has also come in, the advanced cell chemistry. So they help in basically creating the economies of scale for growth in production or manufacturing, you can say, and to reach more heights in terms of the domestic market that we look into, and thereby helping in the exports as well. Then specs come in. It's basically for the development of the electronic supply chain. So in this, there are components that basically get linked, and the companies who participate, they get certain rebates, and in turn, the production is enhanced. For infrastructure and development of the facilities in its own terms, so electronic manufacturing cluster scheme has come in, that is EMS 2.0. So all these schemes, they basically help for enhancement and the production of any particular segment. Here we're talking about the electronics and the mobiles. So that helps. All of these are helping in basically taking the economies to a greater height. So coming to lithium-ion battery, all of you are experts here. So I do not need to actually, go in depth of explanation of it. We all are aware of it. Lithium-ion batteries basically have characteristics for the higher energy density and no memory effect and low self-discharged. And all of these basically for extension of lifetime, then increasing the energy densities, improving the safety parameters, cost reductions, the charging speed, of course. All these are matters which are a base for the R&D. So all of it is already getting developed, but still there are always more and more chances for betterment. These cells are manufactured either to prioritize the energy or the power density into it, not forgetting the safety constraint or the safety compliances that need to be looked into, because if they are mishandled or not taken care of properly, they even can be life-threatening and dangerous as well. It's very rare to hear all of it right now, but initial phases did had all of these issues. Okay, so some numbers again. Market value is basically USD 1.66 to projected to around 4.14 in 2026. As rightly said by others, as well as here the point mentioned, COVID-19 had hit this industry very badly, impacted even other industries. So this basically brought us down for at least 2 years backlog, and henceforth there had been a dip in the market as well. Now coming to the segments which are basically dealing with this, they can be the portable segment of mobile and electronics, as well as the electric vehicles, which are likely to share a major part for the upcoming cycles. Reason why I mentioned here is the BOM, the bill of materials of each segment is mentioned here. They're roughly ranging to about 4 to 8% in a mobile phone. Laptops is 3 to 4. Hearables and wearables, they come under consumer electronics. They have 10 to 15, and wearables roughly around an average of 5 to 6. Stating this point here basically tells you how much range, or what you can say, the part these components have, and how much of it can be actually seen as a source for other, the other segment for recycling. The reason for projection is basically detection of the source and the content, how much can be recycled. This part also can be, looked upon as a, what you can say, input for recycling of the e-waste. E-waste covers other parts as well, but lithium-ion recycling is altogether a separate entity. So this may be helpful for, how much is actually produced each year, how much has been recovered, and then this mathematics can be calculated in a back manner that yes, how much is manufactured is actually recycled or refurbished or not. So in terms of the gigawatt hours, I'll not be spending more time because many of the previous experts who've been talking about this have already explained. So just to throw some light, storage applications that can be considered here would be the consumer electronics, of course. The data centers are there. Then storage, of course, is there, which is either for a power plant or for an electric vehicle, or it can be for a portable storage device as well. So EV's battery size, if we can just go and see, it's a very general number, which is shown as an average. So two-wheeler, it's ranging about 2 kilowatt hours. Three-wheelers for 5, four-wheelers for 15, and subsequently for heavy vehicles, it ranges from 150 to 250 kilowatt hours. Then sales basically are estimated to rise. This I'm talking about the electric vehicles, which will play a major role for the segment that you're trying to look upon as the the lithium-ion batteries. So just talking about the growth of the lithium-ion battery market, I'm looking like EV as a major shareholder in this. So I've just mentioned the National Electric Mobility Plan that was there. Then came in FAME 1 and FAME 2, in which government had leveraged many options just to create the demand, and of course a platform where you could see the EVs getting adopted at a much faster rate. Then of course the PLI we've spoken about has come in, having great opportunities, but then there's a lot of scope in the R&D in terms of all the materials that are being used in batteries for various other characteristics that they can support into. Then the state policies for the faster adoption of EVs, each state has deliberated some of the variations in the policies that do exist, and of course they are helping in the faster adoption. The next comes in the renewable energy. Basically, the renewable energy part comes in as a source of clean energy, of course, and then the storage part is associated with it. So installation of 175 gigawatt of renewable energy by 2022 and 500 gigawatts by 2030. So value chain, if we have a look, then global market has already been shared up before this. So the numbers are projected here. What we should now focus is basically the value chain that we are talking about. The extraction and production of raw material, the speaker before this has actually elaborated much more clearly on this. Cell component comes in, the assembly part comes in, and the fourth one I've highlighted, which is basically the theme of this event, is recycling part. Different type of lithium ion batteries, as discussed by all of the experts. They have been already dealing with lithium cobalt oxide and lithium nickel manganese cobalt oxide. The ferrous part has also come in as NFPs. So there has been, slight deviations in the thought, which has a better adaptability and more of focus to have a better future. So I will not be going into in-depth analysis because the experts are already present here. They have their views. Yeah. So if we can see LCOs, the lithium cobalt oxides, they are specifically having their usage in the portable devices, whereas the nickel manganese cobalt, they are used as in for the medical devices and the EVs. This is just a very generalized chart that is present in which various chemistries of the cell are mentioned. The major metals that has been dealing with it, they are there. And of course, the parameters in which they function in terms of the cost, then in terms of the performance, their power densities and all, they have been clearly mentioned. So it's just a very brief overview, and typical usages can also be seen. Likewise, in LCOs, they are used in the cell phones, laptops, as explained in the previous one. And others where you can see the various chemistries that are being used. They are used in EVs, then power tools, then other medical devices as well. Now, what is the need? Why are we basically looking forward for this? It's the chemistry and the cell basically, or the battery comes in various characteristic parameters that defines its performance over charging and discharging. So which battery will be serving which purpose in which segment of electronics, that's our aim. So basically they reach the end of life, and in various segments sizes do matter. And I also had seen a chart which was actually kept here showing the weight of the batteries as well. Now, why I'm talking about the weights here, because then you actually see the amount of lithium that can actually be recovered from this. So now another point is entire world is shifting towards EV, as the production cost, the production quantity, the production sizes will obviously vary, and it will be mattering a lot in terms of the cost that is also associated with it, depending upon the applications which it is solving. So these would be basically leading to bad batteries, what you can say the dead batteries, that would actually require some process to recycle them or reuse them. Now, key drivers, ma'am from SICRI had already explained us that there's obviously a scarcity of the metals that are being used. So number one, that is the major challenge. Then of course, the associated environmental hazards and the health hazards that are there. If these batteries are not properly recycled, reused, or handled carefully, it may cause serious hazards in terms of degrading the environment. That also causes the GHG emissions, which are leading to the global warming parameter, as well as various health hazards that can be looked upon. The management comes in terms of two aspects. One is basically the second life use, and second one, many of the previous experts have explained, like LI cycle and others. They complete the closed loop process in which the black mass and all its processed and other metals are derived out of it. Why I'm not going into detail, because we are not the experts in that. So these are the two methodologies, just to show that basically it's a short-term solution in which you can use the batteries which have reached the spent batteries. Basically, they still have some life in them. And if they can also serve the purpose from 70 to 80% of the initial capacity, they can actually be used as a secondary source. So all those sources can be basically for power management. Then there is grid stabilization that is there. And of course, for the renewables, they can be used as a storage facility. So that might help. So this is just a very small chart showing the complete life cycle. So you have a new battery from the manufacturing facility, and then you have the source which is using that battery. Battery is getting used. Either it goes to a junkyard, a waste collection system, and else it can be used in a refurbishing company, as we rightly do it for mobile phones as well. Mobile phones also do have an end of life. So after that, either it can be thrown off completely and mishandled, or it can be refurbished and reused. So that actually correlates and explains this part. And then it can be used in a secondary storage. After the complete battery is utilized, it doesn't solve any purpose further for that, then it can be actually gone to the raw material extraction and processing units. And then again, metals can be segregated and then can be used in different segments as per their usage. Okay, so just talking about the challenges, there are lack of policies and the protocols for the reuse. Actually, there is none as far as we are aware of, and people actually don't know when is basically the time that you have to stop using a battery in any device or any vehicle. Then absence of a methodology to ensure the EV manufacturers, they use those batteries which are actually leading to the end of their life, or whether they have been degraded completely and cannot be repurposed or reused again. Then the present recycling processes are able to recover only 50% of the economic value. I'll not be challenging on this question. Moreover, I'll be looking forward to the support, because recent developments have actually increased this number. Then the cost of lithium-ion battery also depends on the chemistry, scale, the volume, the sizes that are needed. Most importantly, the materials that are being utilized. So being from scarce to having none, and then you have the raw material in hand, that is a lithium battery, and then you have to look forward to the perspectives and the methods in which you will be able to recover the metals again. It's a very similar kind of process that goes on with the e-waste generation and collection mechanism, in which previous speakers have already spoken about the awareness part. Here, people are unaware of the culture and the collection mechanism. So, right now with the portable devices, it's just like if you don't want to use it, you throw it off. So there's no particular usage in that. So in that case, you have to have an awareness program and a complete initiative that is taken up by the government, in which you make people aware that yes, this is the kind of methodology. These are the collection bins or the collection spots where you can actually go and drop off the components or the parts that are not getting utilized, so that it may be actually properly recycled and reused again. Long-term solution is basically the closed loop recycling. Direct recycling is the mechanical process. Second one is pyrometallurgical, that is with heat and flame. As explained, that hydrometallurgical would be a better one, because the mechanical pretreatment is done, and then recovery of black mass by means of leaching, precipitation, and other methodologies is done. So that has been explained in depth in detail. Recycling challenges that come in is, it's a complex process, as we all are aware, and I'm also learning new aspects, new technological methods. So it's really a complex one. The cost associated with it, as discussed, lack of awareness that is there. Tapping from B2C segment. This part is basically a prominent one, in which it actually makes the logistical supply chain a very difficult one to deal with. Then comes in the safety part. The safety issues that are associated with it, be the environmental hazards or the health hazards. So that concerns the safety part. And then, of course, comes in the collection and transportation. That is linking the fourth point here. It's quite a difficult one. So if all of these are sorted, there is a proper mechanism that deals with it. Of course, then you're solving this problem. Market opportunity, if just for the battery recycling, if we can say. Okay, so I'm just being told that it has to be short. So just running through. Annual recycling market is expected to grow around 22 to 23 gigawatt hours, which is 1,000 million opportunity. Assumptions here. These are the focal points that need to be considered here. The batteries that are available for the second life use, then other batteries, specifically talking in terms of the vehicles, if we say. Then a second point would be the stationary storage applications that are there. The telecom sector is there. Then telecom sites basically that use these batteries, mobiles, as we've already spoken about. And the, what you can say, life of battery depending upon the vehicle that you're trying to use. Why I'm focusing more on vehicles is basically they are going to share a major value in terms of the batteries that would be reaching the end of life, and of course would be available for the reuse. Just to name some of the key players in the recycling market, we have all these. So it would be, a great platform to share. Just to add on where ICA can support in this, we already work with the Ministry of Electronics and IT. So they have various setups, or you can say the institutions that work along with METI, like CDAC, CMET, and all are there. So we have teamed up with them to form Center of Excellences. One of such is the lithium-ion based products in CDAC Noida that is upcoming right now. And we've also partnered with CMET Hyderabad for the e-waste recycling transfer of technology methodology, in which segments were seen, the various regions in terms of the Indian geography, if you can see. So we had the north and the south region with us. So in that case, recyclers, they join hands and they buy this technology from CMET, and they set up a plant. Of course, the training parameters and the training procedures are done by CMET Hyderabad, the personals from CMET Hyderabad, and then you have your own setup. So in that case, I'm talking about the e-waste recycling and regeneration in this term. So what I'm trying to deliberate here is basically, this is a new segment for us, the lithium-ion batteries also on a whole. So if we are able to pitch in and, we are able to channelize right people with the government as well as with academics and the industry, we'll be more than happy to help. Thank you so much.
Sorry, Arpita, for cutting you down, but It's like paid ka sawal hai. So people are very hungry. So I'm so sorry about it. Thanks, Arpita. If any questions are there, I apologize. We can be having it during lunchtime. She will be there to have the business ideas and collaborative opportunities. Thanks, Arpita. Thank you so much. Just to update the audience on and off, we are having 4 lectures remaining. I know that smile shows me ki kya hone wala hai, but we will be postponing 2 lectures right after lunch. So only 2 lectures are there. So the lectures would be now from Sushma, and she would be speaking it online from India SME Forum.
Good afternoon to you.
Good afternoon, ma'am. Thank you so much. On dot.
Are you able to see my screen?
No, ma'am.
Just a minute, please. Just allow me a second, please. Bear with me. Are you able to see now?
Not exactly. Yeah, it's probably getting streamed up. No, it's now unshared, so you can reshare it again.
It's telling me to stop sharing. Just a second.
Yes, ma'am, there will be a lag in a couple of seconds. Please hold on. It will get updated.
Okay. Okay.
Yes, ma'am. You can just put it on PPT mode. Yes, ma'am. We can see the presentation.
You can see it now?
Yeah, surely.
Is this okay?
That's absolutely clear.
Okay, I will be very, very brief and precise. And thank you very much, Dr. Abhilash, for this opportunity. Good afternoon to all the dignitaries present here. And I thank CSIR to have invited me here for this talk. I have been hearing these the sessions, and they have been extremely technical. But my perspective is going to be purely entrepreneur oriented, because that is what is my expertise. And just for all of those who do not know what India SME Forum is, very briefly, I'm the Director General of India SME Forum. We are a not-for-profit organization, mainly working for the cause and benefit of small and micro, small and medium enterprises. We are 87,000 plus members strong, of which 7,000 plus are women entrepreneurs. These are all manufacturers and service providers spread across India, and who are the employment generators, of this country. So they do call them the backbone of this economy. And primarily, we work towards facilitating, mentoring, hand-holding all these MSMEs. So our expertise revolves around enterprise, entrepreneurship, and entrepreneurial development and entrepreneurial ecosystem. So that's what our expertise is. Now, we have been, I've been given this topic to talk on opportunities for MSMEs in lithium-ion batteries recycling. I'll tell you how entrepreneurs approach any topic. For entrepreneurs, it is very important to understand what the problem is. And only when you see the problem can you arrive at a solution, and that becomes an entrepreneurship opportunity. Now, we have been using so many electronics, mobiles, laptops, cars, cameras, and you name it. And we are creating a hell lot of waste. if you were to see this consumption statistics of these batteries, we are already using up with an annual increase of 18% of the total consumption each year. And it is said that the actual reserves of lithium is going to exhaust in next 30 years. So in 30 to 40 years. So I'm sure you know a lot of things. It's going to be repetitive, but I'm talking about these things for you to understand the problem and see what scope it offers for a possible solution. And that is where an entrepreneurship opportunity lies. India alone uses millions of electronics, and all this electronics goes as e-waste, most of it as landfill, which is not biodegradable, and it lands up contaminating soil, making it infertile, and there are so many only disadvantages to this e-waste. As it is only 1 to 2% of this global waste of lithium batteries is recycled. So you see the opportunity of recycling, only 1 to 2% is being recycled. So there is a hell lot of scope in the recycling industry itself. When you start a recycling business, you need to keep in mind that it's not just about money, but also about how you are going to, deal with ecology, environment, climate, and mainly as a social enterprise. So opportunity for recycling and reuse, it's not just recycling, but it also comes with dealing with health hazards, cleaning, sanitation, and so many other aspects. There are a lot of myths. I'm going to also run through the presentation because wherever it is repetitive, I am not going to talk about it. So as an entrepreneur, there may be a lot of these myths about setting up a recycling unit or recycling industry, wherein, we believe that it requires very high investment and you need the capacity to increase day after day. Yes, it's not just a myth, but yes, it is truth at this point of time, because to set up a manufacturing unit or to set up a recycling plant, you need to have at least a beginning investment of around 50 crores and above to set up a minimum capacity of this plant. And of course, it is only going to grow. The second myth is only a small portion of lithium-ion batteries are recycled and the rest are unfortunately going to landfill. This is again not a myth, but truth. As I explained in my previous slide, that only 1 to 2% of batteries are being recycled and the rest are all going to landfill. So once again, that's a huge scope and it's a very, very profitable industry. Myth: with the right kind of incentives and policy framework, India can leapfrog into EV battery recycling barriers and become a major player. Yes, that is one area where regulatory framework is required, because at this point of time, though our government is talking about use of electric vehicles and introduction of electric vehicles, but they are yet to come out on the parallel framework that is going to be required for the recycling and the waste it's going to generate. So the current opportunity for the Indian MSME is, firstly, India imports all of the lithium ion cells, and we cannot create it here because there is no reserve here. So, we do not have the natural reserve here for this raw material. allow me to just explain one story of one entrepreneur, Atero Recycling India Private Limited. This is one gentleman who, as an entrepreneur, as I said, you know, for an entrepreneur, it starts with a problem and finding a solution. So Mr. Nitin Gupta and Rohan Gupta, the IIT Delhi alumnus, he first realized, you know, the importance of recycling plant. It was only when he could not dispose of his laptop, that's when this idea occurred to him. You know, he started innovating a technology of recycling, and that's when he invested in that technology. They have more than 25 patents to their name, and since then and now, it's one of the biggest recycling plants of this country. They first set it up in Roorkee, Uttarakhand, and thereafter now they have set up in, they intend to set up in 6 other states. They are also open to giving out or opening franchise centers for this recycling plant. So obviously, because they own the technology, and I mean, you know, entrepreneurs who are interested in setting up their plants, they can take the license of these technology or, you know, innovate or invest in finding out a new technology. There are many developed nations who do offer technologies which can, you know, recycle these batteries and play a very, very important role in the recycling industry. The current issues, which also Mr. Gupta wanted to, you know, he wants to address these issues of this recycling industry, is the informal nature of this entire industry, because it includes child labor, health hazards, safety issues. There are no regulations, and these problems, they again translate into a lot of scope and work that needs to be done. You know, this entire process of collection from manufacturers, the e-waste collection from manufacturers to repairers, to recycling, you know, extracting metals in pure form, again infusing this metal in the supply value chain, giving out, you know, selling gold and silver and other pure metal to jewelers. So this entire process has so many different components and layers, and each component and each layer is an opportunity for an MSME to start an industry or start an enterprise in the recycling industry. This is just the current ecosystem in India. The speaker before me did mention about the incentive schemes and that which are existing at the moment. But at the moment, there are no scheme for setting up a recycling industry. The schemes are only present for adoption of EV vehicles. But I'm sure through our entrepreneurs' recommendations and all, we will soon make a representation to the government in what kind of new schemes need to be formed for regularizing and formalizing the recycling industry. And we just say that these are the steps that we need to take at our end to establish India as a recycling hub. So there is a need to automate this entire recycling process, right from collection to infusing the metals in the value chain, supply value chain. We need to improve on the regulations. Government policies need to be looked at and reworked, and battery management rules. Recycling of lithium, ion and nickel cadmium batteries, these rules need to be modified and they need to be up to date. So I'm sure this will definitely go towards making India a recycling hub. And one more food for thought as an entrepreneur. Can we have an alternative to lithium ion batteries? Because there was a time when we had only nickel batteries and lithium was nowhere in picture. So, I mean, that's what is entrepreneurial thinking all about. So with that, I would like to just conclude my speech and urge all the existing entrepreneurs as well as aspiring entrepreneurs and startups to look at the immense possibilities this recycling industry can offer. I mean, at India SME Forum, we are very happy to introduce you to our talent pool, the mentor pool. We have more than 200 mentors who are entrepreneurs themselves from different fields of expertise and industry sectors. And we do have many experts from the recycling industry and waste management industry as well. So we'll be very happy to connect you with them for any entrepreneurial related opportunities in this sector. With that, thank you very much, Dr. Abhilash, and thank you very much for listening to me.
Thank you, ma'am. Thank you for making crisp, precise, and short. And it was actually a very summarized presentation. We would definitely be having you over here in NML sometime very soon. But before we culminate, we have one question from an entrepreneur, a first-generation entrepreneur.
Yes.
Hey, ma'am. Good evening. This is Santosh here. We are a startup, young entrepreneur. So I see a lot of relation with the pitch that you had given.
Yes.
One major thing I wanted to put here in this platform that we're discussing is, as a new entrepreneur setting up an industry for recycling, there's so many SOPs that has to be set from the CPCB, because they're totally not aware of something which is getting a transition. So as a new entry into the sector, we don't have the brand name to leverage that. We already have a process to implement this. So we would request your guidance to take this ahead. I hope.
Absolutely, we'll be very happy to help you out. We'll be very happy to take your technology forward. And definitely, if you would like to pitch your business idea to possible investors also, I mean, we'll be very happy to, help you with that. We can also help you to bring in new technologies from different countries, or even enter into possible joint ventures and collaborations for setting up this business. So we can definitely do that. You may please take my contact from Dr. Abhilash and you can connect with me.
Sure, ma'am. So we are a startup incubator at IIM Bangalore, NSR Cell. So we are already exploring few things in Germany and other parts of the globe through GIZ and NASCOM. So definitely would love to connect and take it ahead. Thank you, ma'am.
Please, you're most welcome. Thank you.
Ma'am, this is Abhilash again. I won't usually do that, Santosh, because now I'm selling my technology, so I won't be allowing you to go outside India. Now we have Anand here.
Hello, madam. This is Anand here from Auto Fiber Craft. We are a local SME based in Jamshedpur. I would like to see your that slide, opportunities for SMEs, once again, because that seems to be very interesting. If you can, please.
I can share the presentation with Dr. Abhilash, because I think they are short of time at the moment.
And madam, one more thing is that like one idea that is coming to my mind is like for this recycling, maybe the battery manufacturers can take back the batteries that they are selling to the consumers, and then they can take it back, and then they can develop the SMEs to recycle these batteries. So
there is an existing mandate. There is an existing mandate where 30% of their waste they have to take back and process it. So if they could make MSMEs as their vendors for recycling, I mean, of course, that is also a very big scope and opportunity.
Yeah. So if you can take this to the government, this idea to the government, and get this implemented, there's a huge opportunity for the MSME industry.
Mandate is existing, but plants are not there. That's the issue. So more and more units need to come up. and because of higher investments, smaller units are unable to set it up. So we need to actually, we are trying to approach the government to make it more viable and incentivize for setting up and help in setting up machinery, help in certain subsidies for bringing these kind of machinery and setting up machinery here in this country. So we are definitely taking that up.
Great. Thank you, ma'am. Abhilash again. It was a pleasure interacting with you, and I know we are targeting this to the grown-up players as well as the young entrepreneurs. So there will be definitely more questions on this. We can probably have a small session later with you directly with the entrepreneurs and literate on this technology.
Sure.
It was a pleasure having you on board, and thank you so much for being there.
Thank you, Dr. Abhilash, for the opportunity. You guys have a great session and keep safe. Thank you.
Sure. Same to you. Take care. Thank you. Just because we all are hungry, so possibly we are breaking down for lunch right now. And when we come back, we'll be having the 3 presentations just before the visit starts. So let us break for lunch. And it would be, I'm so sorry, but it would be very quick lunch. So let's reassemble back very soon. And the lunch would be there exactly the place where you had the high tea. And you can leave your bags here with the laptops, everything. Yeah, we'll be having somebody station who had the lunch. We'll do that. Somebody should be here to take care of it. So you can definitely push off without your baggage for the lunch and come back.